In this video, I will go through the steps to build a spreadsheet simulation model where the demand distribution follows a normal distribution. In this example, we have a department store where the decision is to determine how many heart-shaped boxes of chocolates to order for Valentine's Day. The normal distribution for the demand has a demand distribution where the mean is 175 and a standard deviation of 50 boxes of chocolates. The unit cost for each heart-shaped box of chocolates is $7.50 for the department store. The unit price is $10, so they'll earn $10 for each box of chocolates that they sell. For any boxes of chocolates that are not sold after Valentine's Day, the department store can receive $2.50 refund per box of chocolates. Now, if we simulate this for an order quantity, let's say of 200, to that there, and then what we'll do is we'll simulate 1,000 replications. In another video, we created a simulation for a department store with Valentine's Day chocolates. However, instead of using a normal distribution for the demand distribution, there was a discrete empirical distribution. In that video, we used the VLOOKUP formula together with RAND. In this case, we'll use RAND together with the NORMINV formula. So let's go ahead and get started. So we have one replication, and we'll go +1 all the way down to 1,000. So there'll be 1,018 will give us 1,000 replications. Now, in terms of cell calculation, you can set your calculation options to automatic or to manual. If you want to control when the cells are calculated, which is sometimes what we'd like to do with spreadsheet simulation models, set it to manual, and you can then decide when you want the cells to recalculate. Okay, the first thing is the random number. Just you do a rand function, and that will give us a random number equally likely to be any number between 0 and 1. And then now what we'll do is we'll use the NORMINV function. So NORMINV, and you can do NORMINV or norm.inv, either will work. And then the probability that we'll specify will be the rand. The mean is going to be the parameter that we have here for the mean of our normal distribution. And we'll use $signs to have an absolute reference so that when we copy the formula down, we'll keep the same mean. And then the standard deviation is in cell F5. And again, we'll make that an absolute reference. So we want the random number to change for each replication, but we want to keep the same mean and standard deviation. Now when I do that, you'll see I get a number 170.37. This is because we have decimals here because this is a normal distribution, which is a continuous distribution. If we want an integer value here, one way to do this is to just round the results. So we can round the result of norm.inv B19 F4 F5, and the number of digits that we want is 0, and that will give us a round number 170, and if I recalculate, that number will change. The remaining formulas for the simulation are the exact same formulas as we had with a discrete empirical distribution. The only difference was this main formula related to the demand following a normal distribution. So let's repeat the same formulas that we had in the other video. So the revenue will be the unit price multiplied by either demand or the order quantity, and it depends on whether the order quantity is going to be larger than the demand or smaller than the demand. So one way to do this elegantly is using a min function. So we'll first have B5, and that's going to be an absolute reference for the price that we'll receive in revenue. And then by how many? Well, we'll use the min. It's going to be the minimum of the demand and the order quantity. Of course, if we order 200, in this case, and the demand is 108, we're only going to get revenue for the 108. However, if the demand is larger than 200, we're only going to get revenue of 200. So min of C19, and then we will have B9 as an absolute reference. So when we copy this formula down, we will get the same order quantity, but the demand will change for each replication. Next will be the cost. The cost will be the same for every single replication, just the order quantity times the unit cost. And since we're simulating with the same order quantity of 200, we'll always have B9 times the cost of B4. So that will always be 1500. Next will be the refund. Also depends on whether the order quantity is larger than the demand. So in this case, we can use a max function to ensure that this doesn't go to navigator. So it'll be B6, which is the unit for refund, and then we'll multiply that by the max of 0 and the difference between B9 and C19. And now remember, B9, we want to make sure it doesn't change as we copy the formula down, whereas C19, the demand, we do want that to change. So we'll make sure to have absolute reference on B9, but and a relative reference on C19. And now the profit, of course, is revenue minus cost, but in this case, we also have a refund, so we'll add the refund. So D19 minus E19 plus F19. Now if we copy this down for our 1,000 replications and recalculate the cells, we will have simulated 1,000 iterations of this. Now, if we check to see what values that we're receiving, we did in the previous video, we did a filter and we only had 3 situations. But if you can take a look here, you'll see there's many more options that are happening here when we're simulating running from the normal distribution. So we can't really count how much is happening of each one, and then it'll change. So what we can do though is still compute the average. So the average profit will be the average of the profit column. That'll be G19 to G1018. And then to get the standard deviation, copy the same thing, we'll just change the function. And then if we want to see the minimum, and then the maximum. And if we recalculate the cells, we'll see we get differences. We get some differences that can occur.